I have been hearing Jensen, the NVIDIA CEO, talk about AI as a five-layer cake. He keeps on saying that there are multiple nuances to AI is not only the frontier language models. So whenever you think of a company coming up with its new models, that is not the sovereign AI. That is not the only development that a company needs or that a nation needs to do at its, to build its competitive advantage. So in economics, we keep on using this keyword known as moat. So economic moat or competitive advantage. So Warren Buffett and Charlie Munger used to call it moat, but it simply translates to what is the competitive advantage that you have that cannot be beaten easily with respect to your other competitors, right? So the first layer in AI. So just imagine that we are going to break down AI into multiple layers. So this video is going to help us understand which nation among US and China has better competitive advantage across which layer. So the first layer we're going to talk about is the energy layer, right? So we know that every GPU, let's say all foundational models are run on GPU, right? So we have a training phase, we have an inference phase. For every training phase and for every inference phase, and even for storing data, we need something known as compute, right? We need something known as GPU. All of this translates or boils down to energy consumption, right? So that's why energy is a very important component in the AI stack. Or rather, it's the first component in the AI stack. So if we break down, if we try to correlate transistors to compute, transistors to GPU, a GPU might have billions of transistors. Then similarly, a server might have multiple GPUs, right? Similarly, a rack might have 20 to 40 GPUs or 20 to 40 such servers with dozens of GPUs, right? So we have the baseline stack, which is, let's call them the transistors, then the GPU, then we have one more layer, which is the server, then we have the rack, then the rack is then positioned in a data center. We have a data center that has multiple racks of such servers that contains multiple such GPUs and CPUs. Similarly, each of these now data center further translates into something known as a power substation, and then to the national grid, and then we just go to the bottommost layer, which is where does the energy come from? Does it come from coal, solar, wind? All the energy sources come into the national grid, right? So everything is boiling down to energy. Among US and China, if we evaluate, US is far behind than China in total energy consumption. So China produces something around 9,300 to 10,000 total watt hours. Similarly, US is halfway there. It's 4,400, right? So China is a manufacturing centric economy, right? So naturally and organically, the demands are very high in China, especially with respect to power consumption and power production, since it's a manufacturing led economy. But it also means that China is structured in such a way that it will be able to allocate a major piece of its energy to its AI layer, to its AI stack, to the company, to the country's AI requirements, right? Whereas US is largely behind with respect to production of energy, right? And we know that as we are scaling the model parameters are scaling, the model complexity is scaling, then the training is require more and more GPU. Inference is requiring more and more GPU. Now, how inference would require more and more GPU? So training is one time full flux energy explosion, right? But inference is persistent querying a model. So whenever you query a model, there has to be some energy consumption. Now it might be very light. One query might be very light. One query of inference might be very light with respect to training. But we have millions and billions of QPS on these frontier large language models. So definitely querying or inference time also requires a lot of compute, further a lot of energy. Storage obviously is not that much. So if we try to compare, the most amount of compute and energy is required in case of training, and then maybe inference time, and then maybe storage or storing few model parameters or few weights at a particular place, right? So we can establish here that China has a little more competitive advantage than the US in case of energy production. So China has better production capacity, although it's a manufacturing economy. So the energy requirements there are high, but still China has decent amount of energy production, so such that it can allocate to its AI stack. Now, the second layer, which is the chips layer or the chip layer, we know that NVIDIA dominates the chip world and US kind of has a competitive advantage here. But how? So there are two ways to manufacture these kind of chips. So one is the EUV technology, and then the second is the DUV technology, as mentioned here. So EUV is like the proprietary or the most gold standard one for producing these leading edge chips. But the problem is, due to trade restrictions, China cannot use this particular technology. China has to rely on something like a DUV, which is deep ultraviolet. So this particular DUV strategy requires the Chinese chip manufacturers to do a computation 4 times, right? So it has very low precision and very reduced efficiency. And there's one more problem, that the success rate is only 33%. That means if they're producing 10 chips, 7 chips out of those 10 chips have to be thrown away, right? So it's an older generation technology, right? So why China cannot use EUV? Because there are some export controls China that restricts China to have EUV access. So they have to rely on these advanced DUV multi-patterning, technology to approximate their chips. Now the problem here is that NVIDIA, since they have UEV technology, or the problem or the solution, so NVIDIA has 80% of success rate, right? So and also very low cost per transistor at scale. So if we talk about NVIDIA, since NVIDIA has 80% of success rate, but there's one small problem, that all of these chip manufacturing, especially by NVIDIA and AMD, is being done in the factories which is largely in Taiwan, right? So for China, 7 out of 10 chips have to be thrown. This is one big disadvantage. And for NVIDIA, although they have the world's best blueprint, but the factory is largely in Taiwan. And all the major chip design leaders like NVIDIA, AMD, Apple, they have to rely on TSMC, which is Taiwanese semiconductor manufacturing company. So this also creates a geopolitical choke point, right? So what if TSMC is disrupted? So all of these USAI companies will or might lose the leading edge chip supply, and the AI cost per compute will also again skyrocket because there's very deep dependency. Now let's go back to the next layer, which is the infrastructure layer. So here I will talk about one performance indicator, which is the velocity. What is the velocity here? Let's imagine that the velocity here we are referring to is the ability to ship a new data center or deploy a new data center, right? So since intelligence is the new product, intelligence as a service is what people are running after, or these countries are running after, and now it has become an industrial product. It is deeply dependent on data centers. It is deeply dependent on the speed at which you can give access to these companies, for data, for compute, for power, for everything. So in US, all of these data center timelines are around 24 to 36 months. That means it takes US 36 months or 3 years to set up one data center, right? They have to undergo a lot of paperwork and approvals. They have grid interconnection studies, then they have litigation as a blocker, they have zoning approvals as a blocker. Since there are a lot of institutions, they have high institutional friction. But when it comes to China, they have this paradigm of setting up a hospital on a weekend, right? So now they think with that mindset that speed and velocity is what can help us win. So there they can set up a hospital in a weekend. That means they can also set up a data center in order of quarters or maybe order of 6 months, right? The way they have kind of structured their data centers is also very clever. So all the high training resources or all the high training compute resource centric data centers are lying in one region, and all the user data, all the PII data, all the user-centric data is lying in on one side of the data center, which is the east, right? So this is how they have kind of structured it, and but they have a very significant edge in producing, or they have a very significant edge in velocity, the ability to ship a data center in 6 months, whereas US is very much private and requires tons of approvals and layers and layers of approvals. They take a lot of time to set up one data center. So the strategy for China here is definitely helping China win, because the velocity, it creates more and more velocity gap, right? Whereas in case of US, the cost is also very high. The power cost is significantly high as compared to Chinese facilities. In China, it only takes 3 cents per kilowatt hour power cost, but in the US, the cost might be 4x higher. Now let's talk about the most important layer, which is the most commonly heard of, the model layer, where we have all the models lying with these particular countries. US has more than 40 notable models that have exceeded the benchmarks, and that are, they are leading in the frontier or the foundational model race. They have one of the best, smartest models that are deployed and that they have been commercializing on. But whereas the approach to China is a little different. So China tried to open source all of its model. China is kind of winning in the strategy such that it leads the open source space. The second thing is that all of these open source models are highly used by the developer community, right? Since they are open sourced, developers can make multiple inference calls per second to these open source model and can rely on them. Most of the developers come from the US. The US is like the first country to have the highest developer cohort. Then the second is China, right? What it also means is, although US owns the frontier large language models, but most of the US developers are relying on China's open source models because they are free, they are cost effective, they are compute effective. So the AI usage cost per query definitely is lower in case of Chinese models, right? And they are 95 to 96% as smart as the frontier foundational models, right? So we have one more interesting stat. So Hugging Face, which is the biggest model repository, there Quen, which is a Chinese model which was open sourced, surpassed Meta's Llama on Hugging Face, which is a great insight that although US might be the best in frontier large language models and they might have been a great opponent with China in productionizing AI at a commercial consumer space, but open source is definitely led by China, and Chinese models are kind of creating dependencies on these, US developer cohort. So the US developer cohort means 70 to 80% of the US startups. All of these US startups want to make money. They want the enterprise AI cost to be as lesser as possible. So since they want to have a cost advantage, they rely on these Chinese models. So one more factor also is the training cost. So if we look at the training cost of DeepSeek V3 and compare it with a typical frontier model like a GPT-4, the cost for DeepSeek V3 was $6 million, whereas the US frontier model costed hundreds of millions of dollars. Now let's talk about the application layer, which is the last layer. Now, how since we have developed this particular technology known as AI, and we have discussed it with respect to multiple layers and multiple perspectives, how is the sentiment in each of these economies and each of these countries? What are the applications? So we know that China is very much manufacturing centric and US is very much SaaS centric, right? So obviously the first adoption that is going to come in US is going to be around software. US wants to push itself as a software driven economy, whereas China is a manufacturing driven economy, right? Now, if we talk about trust, right? Since we're talking about sentiment and application both, let's talk about sentiment. Sentiment is like, how is the trust? What is the sentiment? Is it extremely positive? Is it extremely negative? Is it very optimistic or is it very pessimistic? If we talk about the US, right? In US, there is some greed, obviously, to make a lot of money in the AI hype, and there is also a lot of fear in consumers, right? So since US is more fragmented and politically polarized, the US sentiment is more, debates around job loss and safety and ethics. But whereas in China, institutional messaging works a lot, a central messaging works a lot. So there is little better trust, and it does not mean that Chinese people trust the Chinese government indefinitely, but there is still a lot of trust, and there is a collective optimism around the whole tech ecosystem, around the whole AI ecosystem, right? So it's a little, the trust index with respect to AI in both the countries, China still wins, whereas the youth, the adoption, so in case of China, the adoption is more industrial, right? Since China is manufacturing based economy and US, the adoption is going to be more towards SaaS, right? The strength of the US is SaaS. And we have seen a lot of companies like Microsoft, OpenAI, they have come up with their enterprise co-pilots, and a lot of SaaS companies adopting the AI in order to, produce that applicative ecosystem effect that, one technology that comes out and everyone tends to adopt it to make money. Right. So in US, we've seen this a lot, especially in the SaaS area and the consumer AI apps. In case of US, the more advantages are that it's a software first economy. It's very high SaaS penetration. It's a service heavy GDP. So AI kind of becomes a knowledge worker here, right? But when we come to China, China is more manufacturing heavy, more industrial, more infrastructure heavy, more logistics heavy, right? So the AI deployment or the AI adoption first will focus on smart factories, industrial automation, the supply chain optimization, surveillance, computer vision. All of the major Chinese companies like Huawei and Baidu, they're deeply embedded in industrial AI, right? They know because here we can win and have a competitive advantage in AI because the economy kind of is structured that way that we can win in case of industrial AI. So China's application layer strength is very much different than the US, but definitely, it has its own pros and it has its own cons. Both of them are focusing on different fragments of the market. So just to summarize application, if the metric in case of application is the AI SaaS startups, then US wins. If it is more developer tools, then obviously US wins or US leads. If it is around VC funded generative AI apps, then US leads. But if the metric is around application layer with respect to industrial AI deployment, then China wins. Application layer with respect to state AI integration, then China wins. Then if application layer with respect to AI in public infrastructure, then obviously China wins, right? So both of them have their own ways of adopting and integrating the applications of AI in their own products, teams, corporations, workflows, organizations. They have their own advantages and they have their own disadvantages, right? Now, if we talk about who is winning this AI race, right? So we can have two perspectives to view this particular race. One is the marathon and one is the sprint. So if we think about marathon, right, a very long runway, then obviously US is leading because US owns the frontier model intelligence and also the adoption, right? US kind of have commercialized everything around all of these frontier language models, and they have core AI research labs. China is great at copying and copying with speed, but US has core research labs, core AI labs. So they have the world's most or the world's best blueprints for chip manufacturing, which is the most advanced semiconductor design, and they attract the best resources, the best top tier AI talent, and they have great access to capital also, right? So US leads that way. I mean, US has a lot of long term assets, whereas if we talk about China and view the race as a sprint, as a short term sprint. So China obviously leads there. So they have structural advantage in energy capacity. They can produce more. They have natural demands for energy more. It's a manufacturing industry. It's a manufacturing economy. So naturally they are energy heavy, and the production capacity for energy is almost close to double than the US. And the demand for US is only 2%, but China, the demand for energy is close to 6%, 6 to 7%, right? So the velocity, they are far ahead in velocity. The ability to ship a new data center and come up with a new data center is 3 times faster than the US. If US can take 3 years, they can come up with it in 6 to 12 months, right? In order of months. So industrial AI. So they are great in industrial AI. They have deep AI integration in manufacturing since it's a manufacturing economy. And the dominance in open source AI movement, they took a contrarian approach. Instead of commercializing and productizing all of the open source, all the models, all of the frontier models, they kind of open sourced it to just crowdsource the whole, development with the developer cohort, right? So when you open source, naturally the adoption becomes greater and developer starts to contribute, give you feedback, and you evolve at a faster and a better pace with more and more iterations. That's why open source helps. So they have dominance at particular area, and the progress towards self-sufficient AI stack, I mean, yeah, so they are trying to build their own AI stack, which is known as sovereign AI. They have all of these layers in house, right? So both of the countries have their own structural advantages and disadvantages. So if we look at the AI race as a marathon, US kind of is leading and has long-term assets. If we look at China, then and if we look at AI as a sprint, as a short race, then obviously China is kind of leading. Thank you. I hope this particular video was insightful and we got a geopolitical perspective on both the economies and what their perspectives are and what their next steps of strategy would be and how they look at AI.